In our previous video, we took a look at how we can add and subtract to solve for x. Here we're going to take a look at how we can multiply and divide to solve for x, using the exact same model we saw before, but now our equations are going to be something like 3x equals 12. And notice that's different than x plus 3 or 3 plus x. When it says 3x, that means I have 3 of these x strips. And then it's going to be equal to these 12 positives on the right. There, I think I have 12. What we're going to do, though, is we're going to be interested in how we can see what exactly one of these strips are. So when I do that, I'm going to split these strips up into 3 groups. And we're going to do the same thing with these 12 positives. If I split these 12 positives into 3 equal groups, what you'll notice is each group of x has exactly 4 positives in it. Now, operationally, what just happened there is we said 3x equals 12. And if we balance on that equal sign, we've got 3 x's that we divided up into 3 groups. So we divide to divide into 3 groups. And we know if we divide one side, we have to make that same division or split into groups on the other side. And that reduces out the 3's so that we have x is equal to 12 divided by 3 is 4. Each one of those x's had 4 in it. Another thing that we can do is we can see negative x is equal to a number like 5. If I balance on the equal sign, a negative x is represented with a negative strip. And then we've got 5 positives on the other side. What we're going to do is we know negative means the opposite. And so what we're going to do is we're going to flip over our negative strip and make it into a positive strip. But if I do that and I flip over the left side, I also have to flip over the right side. So all those positives get flipped over, and they all become negatives. In other words, we end up with a x on the left and 5 negatives on the right. So those x's represent 5 negative chips. Working out the algorithm, what we just did there, though, balancing on the equal sign, when we flip things over, that's going to operationally be equal to dividing by a -1. A -1 flips the sign, because a negative divided by a negative is a positive. And so x is equal to 5 divided by -1 is -5. Kind of what that might look like on a bigger problem is I might have -8 of these x's. And it's equal to 72 chips. Now, I'm not going to draw out 72 chips. But what we can see is if we balance on the equal sign, we need to divide those 8 x's, those 8 individual x strips, up into 8 groups. But because they're negative, we need the opposite side of them. So we'll flip them all over with a -8. Dividing both sides by -8, then, -8 divided by -8 is 1 x strip left. And 72 divided by -8 is -9. And so we would know x is -9. We can also look at a division problem. How about x divided by 3 equals -2? Well, what this essentially looks like, if I were to draw a picture, is we've got this positive x strip. But we're not going to do the whole thing. We're just going to do 1/3 of the x strip is represented by those 2 negatives. So I've kind of made it into a fraction, 1/3. Well, then if I think about if I had another x strip and I shaded the middle third, that middle third would also have 2 negatives. And so if I think of another x strip where I had the right third, that right third would also have 2 negatives in it. Essentially, what I've done is I've taken that 1/3 and I multiplied it by 3, filling in each of those thirds to give me a total strip that's now shaded all the way in. How about I have an equal sign on here? And that's balancing out with 1, 2, 3, 4, 5, 6 negative tiles. In other words, 1 full x balances with 6 negatives. Essentially, what we did in our problem of x divided by 3 equals -2 is we said to get rid of that divide by 3, to get rid of that 1/3, we need to think about that happening 3 times. So we multiplied by 3 on both sides, so the 3's could reduce out, and we're left with x equals a -6.